broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, or good evening to everybody who's joining our webinar, wherever you are in the world. And welcome to this joint Smart Villages, LCEDN and HPNet webinar, which today is on the subject of resilience and reliability of energy projects in Nepal. Just to briefly introduce the three organisations who are co-hosting this. Smart Villages is an initiative that has been running for around 7 years now, working on the belief that people in remote villages deserve the same opportunities as everybody else in the world, and looking at how access to energy and access to other innovative technologies can really catalyse that whole integrated development story. We collaborate with organisations all around the world to look at what some of the best ways are to achieve that, and to try to get that to actually work on the ground in villages. Our partners at the Low Carbon Energy for Development Network in the UK are working with us in this initiative and in many others. The LCEDN brings together researchers, policymakers and practitioners throughout the UK and partners all around the world to discuss these issues and work on them in a number of different projects. And it's centred around hubs which are run out of the Durham Energy Institute at the University of Durham and Loughborough University, which is hosted there also on behalf of the Midlands Energy Consortium. Our third partner, which is HPNet, the Hydro Empowerment Network. I will let my co-host, Ms. Dipti Vigela, introduce that organisation and indeed introduce a little about the topic of the webinar in just a moment after I have gone through the format of the webinar, just so that everybody participating is clear on what we're going to do. So after the introductions, we will run 2 polls for all of the participants who are taking part remotely today. The first poll will ask you all to enter a button to tell us where in the world you are joining us from. That's just so that we get a little idea of where people are coming from and who is participating in this live webinar. The second poll then asks what sector you work in. So whether you are a policymaker, or maybe you're an entrepreneur, or a researcher, or somebody coming from the NGO side, or somebody from a different sector. And again, that just lets our speakers address their comments a little more accurately to the knowledge and the interests of the group that is joining us. So we will run those polls after the introduction, and then we will go straight on to introduce our 3 speakers, who today are Dr. Longseng To, Joe Butchers, and Jiwan Kumar Malik. And we'll introduce those a little bit later on, after my colleague has given us the introduction from HPNet. So, Dipti, would you like to introduce your organisation a little bit and tell us more about the topic of today's webinar?
Yes, thank you everyone for joining today's webinar. The Hydro Empowerment Network, HPNet, is a knowledge exchange and advocacy platform bringing together multi-actors to advance small-scale practitioners of hydropower in South and Southeast Asia, and now we also include practitioners from African regions. We focus on the themes of not just technology development and innovation, but also policy and financing mechanisms, and most importantly on socio-environment gaps and themes that actually are at the center of sustainable small-scale hydropower. The capacity that we focus on are projects below 1 megawatt, and we support a spectrum of practitioners, including grassroots NGOs, civil society organizations, local entrepreneurs, and private sector. And we work with multi-actors, including researchers, development agencies, and government actors to create advanced enabling environments in our focus countries. So currently in South and Southeast Asia, you can go to hpnet.org and see our focus countries. And today's webinar, I'm very glad to share, focuses on Nepal. You know, hydropower in Nepal started nearly, or the development aid focus of small-scale hydropower in Nepal started nearly 3 decades ago. And so Nepal really has been our forerunner. Several of the other regions look toward Nepal, its hindsight and what it's doing now in order to develop our current work. So some of the key focus areas actually on resilience. How do these projects live after they are implemented? And how do the processes of implementing them link to how long they are lived? And so some of the themes that we have been focused on and learning from Nepal practitioners, as well as supporting them, include different ownership and management structures, such as community-based or enterprise-based, financing structures, whether they include grants or subsidies or loans. And on the technology side, we are realizing that Nepal is really leading in this area of what happens when the grid arrives. So there are contexts within our network, such as Sri Lanka, Indonesia, which have already gone forward in interconnecting small-scale hydro to the main grid, where communities actually generate income by feeding clean energy into the main grid. In Nepal, this has actually unfolded into an established policy. And so I will stop there and let our speakers present on the action, research, and practitioner areas of their focus. Thank you.
Great. Thank you very much for that, Dipti. That was a great introduction to why we are holding this webinar on this particular topic today. So before we progress with the individual presentations, I just wanted to let everybody know at the end of the three presentations, we will have a question and answer session. If anybody has a question, there is a mechanism on your system for you to enter that question, type in that question, and it will be transmitted here to us, and we will allocate that question either to one of the speakers to answer, or for the 3 speakers together to discuss that question at the end. The recording of the webinar and all 3 presentations will also be available via our website and our partners' websites after the end of the webinar. So without further ado, I would like to invite our first speaker, Dr. Longseng To from Loughborough University, to give the first presentation. Over to you, Longseng. And don't forget to unmute yourself.
Great. Thank you very much for the invitation. I'm looking forward to a fascinating discussion learning from the Nepal experience on resilience. So what I want to do today is to introduce you to a process that I'm leading on building research collaborations for community energy resilience in low-income countries, and then talk specifically about the South Asian context and our recent activities in Nepal. So, what I'm going to speak about today is a research collaboration project, so a networking project that is a collaboration between the Low Carbon Energy for Development Network and the Applied Research Programme for Energy and Economic Growth, which is led by Oxford Policy Management. We also receive funding from the UK Energy Research Centre through their Whole Systems Network networking fund as well. So the focus for this collaboration is to look at opportunities for increasing community energy resilience in on-grid, mini-grid and standalone electricity systems in South Asia and Sub-Saharan Africa. So what is resilience? I really like this definition from the Red Cross, which is that resilience is the ability for individuals, communities, organizations, or countries exposed to disasters, crises, and underlying vulnerabilities to anticipate, prepare for, reduce the impact of, cope with, and recover from the effects of shocks and stresses without compromising their long-term prospects. I like this definition because it works across multiple scales and also looks at both short-term and long-term issues. Why focus on community energy resilience? It really comes from an observation of households and from communities that they really make use of energy in a strategic way, both in disaster situations and their everyday life, to improve their resilience. So, for example, in the earthquake in Nepal in 2015, afterwards, communities really activated their informal networks in order to access energy. Also, because there were changes to the energy mix, people tended to diversify the sources of energy that they were using, fuel stacking. So I think this kind of strategic use of energy needs to be acknowledged in our planning processes. So at the moment, we still plan and give aid in a way that just looks at communities as consumers of energy rather than this kind of active participant. And we're really wanting to explore the implications of that. Could we deliver better energy services more quickly and more cheaply by not looking at the world as divided perhaps between those who will get access via grid, mini-grid, or standalone systems separately. Perhaps it's a mix of these, and perhaps it will become more of a resilient system. So in terms of the networking project itself, it's really to facilitate knowledge exchange between different sectors and between countries, so between UK, South Asia, and Sub-Saharan Africa, to identify up-and-coming research opportunities as well as opportunities for future funding proposals as well. And that revolves around events, so in-person workshops. We've had 3 events so far. So one session at the LCEDN's annual conference in Loughborough in the middle of last year, followed by 2 workshops which have happened already in the UK and in Nepal, and one upcoming one in Malawi. They're associated, we plan to put out written outputs as well from these workshops. And the very first output of that, I've provided a link below. It's a summary of the first session at the LCEDN annual conference. So I wanted to give you a bit of a summary of the UK workshop, even though that's not the focus of today's talk. At that particular workshop, we looked at how electricity systems might become robust enough, and how does that interact with energy resilience? How does it contribute to energy resilience? And then how does energy resilience contribute to broader community resilience? And then the overall governance structures that enable that resilience to happen. So I think 3 things stood out for me from that workshop, which was it confirmed the need for research at each one of these boundaries between physical systems, energy resilience, community resilience, and governance. The need to focus on energy services. So actually, at the very core of this diagram, it should really read energy services. What does the electricity system actually deliver? And the need for inclusion and capacity development across all of these levels also came to the fore. So actually this month, we held a workshop for the South Asia region, including 5 countries from that region. And it was held in Kathmandu in Nepal. So it was a very there was quite a lot of focus on Nepal as a case study. So at the workshop, we did use the disaster risk reduction cycle as a lens to look at energy. So that involves the response, the recovery, the mitigation, and the preparedness aspects of a disaster. So from short-term to the long-term issues. At the workshop, we discussed the energy and resilience situation in South Asia. So what were the most critical energy services, especially for the most vulnerable communities? What were the major vulnerabilities in the electricity system? And how does energy fit into that wider understanding of resilience? And that was really fascinating discussion with sharing from the different country experiences. In terms of identifying research needs, we split those into two groups, so sort of a short-term disaster response and recovery, and then after that we discussed prevention and preparation. So we looked at, tried to really identify specific research questions to do with those, especially focusing on the opportunities for on-grid, mini-grid and standalone systems and how they might interact, but also the role of different actors such as community groups, private sector and the government. So here are some of the emerging questions that came out of each one of those sessions. So we discussed the role of quality control guidelines as a way to enhance the reliability of systems and therefore the resilience. The integration of mini-grids into national grids and how that might offer opportunities or challenges for energy resilience. We weighed up the costs and benefits of renewable energy systems with the ones with more backup that cost more but might be more resilient. So cost-benefit analysis that can be done there. And also the actions required across operational, regional and national level planning that would improve resilience as well. In terms of the short-term actions for disaster response and recovery, we discussed the role of energy efficiency in energy resilience, the specific challenges faced by informal urban communities and the communities being displaced were also discussed. The critical capacity of community organizations really came to the fore, especially in discussions about Nepal. So after the earthquake in 2015, community groups such as the electricity users associations played a critical role in rebuilding some of the infrastructure and identifying the needs. And so, that also led to discussions on how to build back better straight away and to include energy in those reconstruction plans more effectively. The idea of productive uses of energy was also discussed as a way to link livelihoods and resilience and disaster risk reduction as well. And finally, in terms of those more long-term prevention and preparation steps, we felt that it was critical to look at the changing nature of exposure to risks of different communities and countries. Could be due to things like climate change and other changes, the natural and the built systems that we're talking about, the users and managers of energy, and finally the institutions, the rules and regulations. So we felt that these were critical components of energy resilience. In that, there was a strong role for social capital, and also many countries experienced shocks recently in terms of their energy supply. So energy security was also a big topic of discussion. So in terms of next steps for the project, I really look forward to the discussions in sub-Saharan Africa coming up soon, and also that we will be prioritizing these these research questions and developing research around those. So I really encourage you to look us up and to participate. So here's my email address and the websites for further information as well.
Super. Thank you so much for that, Longseng. That was really fascinating. I have just realised I owe everybody an apology because so keen was I to get the presentations introduced that I forgot to run the 2 polls that I was promising everybody that we would run. So before we move on to the next presentation, if I may, I would like to run the 2 polls that we discussed. So first of all, we're running this poll about where people are based in the world. So if you could all click on an appropriate button. Results are still coming in. I'll give it another 5 seconds. Right, so roughly half of our participants are based in Europe. Around 20% are from the Asia-Pacific region. Good evening to all of you. I know it's late for you. 15% from South Asia and the Middle East, and a very brave 10% of participants from the Americas and the Caribbean who are joining us very early in their morning. Thank you. And now the second poll, just to see the types of sectors that people are working in. What is your professional background? And the results are still coming in for that. I'll give this another 5 seconds. So roughly half of participants from an academic or a research background, 30% from NGOs and the non-profit sector, and 15% are from the private sector or entrepreneurs. So thank you very much for sharing that with us. That will enable us to bear in mind who our audience is when we're making the rest of the presentations and also going into the Q&A session. I remind you to enter any questions that you have into the system, and then we can allocate them to individual speakers here, or we can put them on the list for discussion at the end. So now, without any further ado, I would like to hand over to our next speaker, who is Joe Butchers. And Joe is a doctoral researcher at the University of Bristol. So over to you, Joe. We look forward to hearing from you.
Hello, everybody around the world. So today I'm going to be talking about a study that we conducted to investigate the reliability of micro hydropower plants in Nepal from technical, economic and social perspectives. This project was conducted by the University of Bristol, where I'm based, the People, Energy and Environment Development Association, an NGO based in Kathmandu, Nepal, and Coventry University are also based in the UK. And the project was funded by the Cabot Institute, who are also based at the University of Bristol. So a quick overview, I'm going to talk about the background, motivation and method for this project, and then just give you a summary of some of the technical, economic and social findings and connect them together to look into how they affect the reliability of schemes. I'll also talk a little bit about my ongoing research, and I'd just like to mention that this research was presented at the Global Humanitarian Technology Conference, so there is actually a paper online for anyone who's interested to read more. So a short background about micro hydropower in Nepal. So micro hydropower refers to electricity generation at less than 100 kilowatts, and there's an estimated 3,300 of these plants in Nepal. The equipment for these plants is manufactured by Nepali companies. The Alternative Energy Promotion Center, who are a governmental organization, along with other national level programs, provide a subsidy between 40 to 60%, depending on how remote a community is. The remaining finance usually comes from local government, with community making a contribution themselves. And communities will also generally provide labour during construction and installation, and that's what you can see in the photo on this slide. Operators and managers for the plants will also be selected for the local community, and operators will typically receive 22 days of training from the Nepal Micro Hydro Development Association, and in some cases managers will receive some form of training as well. The motivation for this research was based on trying to understand the interaction between the different actors who are involved in a micro hydropower scheme. So we wanted to see what is the interaction between operators, managers, community, and the technology. In trying to understand these relationships, we wanted to understand how they affect the reliability of the scheme. So to do this, we visited 24 sites in Baglung and Gulmi districts of Nepal. The sites that we visited ranged in rated power from 18 kilowatts to 135 kilowatts. And for those sites, the number of connected households ranged from around 50 up to nearly 1,800. At these sites, the turbines were the two main types found in Nepal, Crossflow and Pelton. For each site, we conducted an interview with a consumer to try and understand their opinions and behaviours, and also with managers and plant operators to try and understand their roles and responsibilities. We also conducted a quantitative assessment of maintenance on a 1 to 5 scale, where 5 was an excellent standard of maintenance, at 10 subsystems, so starting where water is diverted from the river and working down to the turbine itself. I'd just like to start by showing you some of the images that we collected. So this was a site where we saw a really excellent standard of maintenance, a very tidy, clean powerhouse with a tool rack on the wall, tidy cabling, generally an excellent area in which to work. Conversely, we saw some sites where the standard of maintenance was very poor. You can see that this one is dirty with clutter in the corner. There's a bag over the valve to prevent leakage. It doesn't represent a good standard for reliability. This graph shows across all the sites the average scores for maintenance. The sites with orange bars are those which had untrained operators. And you can see that amongst these sites, 7 of the worst 9 sites were those with untrained operators. And for the sites with untrained operators, at 6 of these, so 6 out of 9, an operator had been trained, but then they'd moved away to find work elsewhere. I would like to move on to talk about the electricity tariffs. So in every case, all apart from one site, payment was charged based on electricity meter readings for both consumers and productive end uses. There was quite a considerable variation in the base rate, from 100 Nepali rupees for 20 kilowatt hours up to 100 Nepali rupees for 4 kilowatt hours, so a difference in a factor of 5. In terms of collecting the tariffs, in the sites that we visited, the larger sites, so those greater than 50 kilowatts, tended to be located in more urban areas. At these sites, it was far easier for managers to collect the tariffs, usually because there was an office or multiple offices where consumers would come and pay in a certain period in a month. For sites with more dispersed houses, it was far more difficult to collect their incomes. At some sites, managers would have to walk up to 6 hours to collect money from the consumers, or consumers would be arranged into groups and be expected to collect the money themselves and then bring it to the plant manager. For the consumers themselves, benefits of hydropower plants are well known, but I'd just like to look into these in a little bit more detail from what we saw. So people mentioned savings in time, money, health improvements, and benefits in terms of leisure. The area I'd like to focus on is the financial savings. We asked the consumers what they would do when the hydropower plant was broken. So what alternative arrangements they would make in terms of energy and how much this would cost. In almost every case, the alternative forms of energy, such as candles, kerosene, or battery charged lightings, were significantly more expensive. This quote here is a typical response from a consumer, where they would pay 500 Nepali rupees for lighting based on kerosene, rather than 100 Nepali rupees if they were getting electricity from the hydropower plant. This showed a general sense amongst consumers of being somehow reliant on the plant. And this quote also helps to demonstrate that. It's difficult when the plant is shut down and creates problems even if it is off for 1 or 2 days. So do the benefits to consumers make them reliable? When we asked managers if consumers paid regularly, at 79% of sites, the answers were yes, or yes mostly. And consumers also demonstrated an awareness of the consequences of not paying their tariff. Society shouts if the bill is not paid, and also salaries will not be paid, maintenance repairs will not be on time. So was the income being collected sufficient? We asked managers, when there has been technical problems, has there been enough money to pay for repairs? Amongst the 8 larger plants, those greater than 50 kilowatts, this did appear to be the case, as they all said that they've been able to pay for repairs when there have been technical problems. The pie chart shows the results for the smaller plants, those less than 50 kilowatts, and you can see the responses were much more varied. I'd like to summarize our findings around in a couple of areas. So firstly, we found that reliability is transient. So whilst trained operators did deliver a higher standard of maintenance, we saw that if they made a choice to move away, the reliability of the plant would suffer because that knowledge was not transferred. We also found that both technical and socio-economic problems can initiate and develop a number of project stages. So a technical example of this is shown in the picture here. We saw plants where leakage was a common problem, which can harm the reliability but also reduces the performance of the plants. What we were unable to tell from the study was whether this problem of leakage was occurring at the maintenance stage or if it in fact developed earlier during design and manufacture and then got worse over time. We also found that the plant income can be unreliable. So this is based on the fact sometimes managers might struggle to collect all the income, sometimes consumers will struggle to pay. And the result of this is an unsteady plant income, which might mean when technical problems occur, there isn't sufficient income to pay for the repairs. This is connected to the fact that reliability is economic and social. So we found the income of plants to be highly variable. I'm sure it's a familiar concept that the number of connected households and end uses will directly affect the income of the plant. But what we found in this study was that the geography of the site, so how far away the consumers were and their income and the tariff structure also affected the income and therefore the reliability of the plant. But what we did see was that consumers were mostly reliable, and that if the plant wasn't working, they were willing to pay more for alternative energy sources. So what this all suggests is that tariff setting and the methods for collection need to work for both the community so that they are able to pay the right amount at the right time, and for the technology so that there's sufficient income there so that when problems occur, repairs can be paid for. My ongoing work in my research is looking at some of these problems that affect the reliability and trying to pinpoint where they first occur during a project life cycle. So can we look for an opportunity to prevent a problem that occurs during operation way back in the design stage? To do this, we're conducting a survey and observation of manufacturers fairly soon to try and understand a bit more about their approach to the whole project process. And hopefully from this, we might find some opportunities to improve the reliability through design changes, but also in recommendations to the whole project process. Thank you very much for listening.
Thanks very much for that, Joe. That was a fascinating presentation, and I can see that some questions have already been sent in by our participants. So once again, if anybody else is keen to send in questions, please do so, and we will ask all those questions of our presenters at the end of the session. So for our third and final presentation, before we get on to the Q&A session, I would like to throw the virtual microphone over to Mr. Jiwan Kumar Malik, who is a solar power expert at RERL in Nepal, and he's also the focal person for APC on grid interconnection of renewable energy technologies. So our expert on the ground in Kathmandu right now. So over to you, Jiwan. We're looking forward to hearing your presentation. And don't forget to unmute yourself. You're still muted at the moment, Jiwan.
Hello.
Hi. Okay. Go ahead, Jiwan. We're listening. We can hear you now.
Hello, people around the world. I'm going to talk about mini micro hydropower in Nepal, and a little bit about background of hydropower in Nepal. If you can see this off-grid and on-grid. In total, on-grid capacity is 1070 megawatt, and in off-grid, it's 25 megawatt of 2500 micro mini hydropower plants, and it serves around 250,000 households in Nepal. And little bit electricity consumption in Nepal, if you will compare with our neighboring country, India and China and world, we are very poor in per capita electricity consumption. It's just 146. So government of Nepal has now target for 700 units in next 5 years, and then 1500 units in next 10 years. So in terms of renewable energy targets and international commitments, government of Nepal is committed to meet the SDG 7 commitment, and in this 99% of households will have access to electricity by 2030, and only 10% of households shall be using firewood for cooking, and there will be generation for at least 10,000 megawatt electricity. And also there is a target for reducing the energy intensity by 0.8% per annum. So in terms of renewable energy target, right now we have a very less renewable energy contribution in total energy wheel. It's less than 1%, and it's a target for 10% renewable energy share in the total energy wheel. And also in the electricity sector, it's a target to achieve at least 30% renewable energy target in total electricity wheel. So in terms of micro mini hydropower in Nepal, as I said, Nepal has successfully demonstrated 2500 micro hydropower plants in Nepal, and there is a direct relationship between economic growth. It's basically when we go for the micro hydro, it's a perception that micro hydro can only provide the electricity access in terms of few electric bulb, mobile charging, and some entertainment system, maybe radio and television. But in our policy, Nepal's micro hydro and renewable energy subsidy policy clearly state that micro hydro shall be linked with the economic growth, meaning that there shall be productive in the use along with the consumptive use in the bulbs. So in terms of productive in the usage, like soap, soap factory, poultry, paper mills, etc. It is making really positive impact on the economy of rural community, not only providing the electricity access only. So the APC is the main apex body for the government of Nepal for promotion of renewable energy technology in Nepal. And APC is also providing some technical and financial support for incentive for the edge micro hydro plants in Nepal. If they have some sort of flood or damage due to flood or maybe some natural disaster, government Nepal again go back and provide some kind of technical support as well as financial support, and that is just some kind of additional subsidy, you can say. So, like in previous presenter, he was mentioning about the operation and maintenance of micro hydro, and it's really linked with the tariff. It's and we have found that in some cases we really struggle with the tariff collection as well as the poor maintenance and operation of micro hydro power plants, and this leads to think us that we should move ahead with the new modality like commercial operation of the micro hydro plants. So we have recently started commercial of micro hydro operation in some of the plants, and it's really gives the very positive impact on maintenance and operation and reliability of the power plant as well. And APC and other some donor agencies in Nepal now realize that there is a time to move from the subsidy-based mechanism to market-driven mechanism, and this is a really challenge now. And DFID is coming up with the new modality, and hopefully this DFID will be demonstrating some of the projects in Nepal to move ahead with the market-driven business model rather than only subsidy-based mechanisms. So far, Nepal is practicing. And also APC is engaging to partnership with the private sector for more economical viable business oriented off-grid systems. Like we are encouraging private sector to come up with the kilowatt hour subsidy, that is a kind of service based mechanism. And also we have energy service provider model, a special purpose vehicle model, and some other models we are trying to pilot in Nepal apart from the subsidy model. So in terms of just link with this objective of the seminar, I'm linking the post-disaster need assessment of renewable energy technology. So in 2015 earthquake, the total loss and damage of grid sector has happened around 60 million of USD. You can see from the table that in the first row, the micro hydropower, small solar home systems, and institutional power systems. These altogether cause the total damage of 43.6 million USD. And in terms of micro hydro, there was a damage of 260 micro hydro plants. And similarly, in solar systems, 115,000 solar systems. And similarly, we, as I said, that we also promote some product wind usage in the catchment area of micro hydro systems. So there was some losses in the income generating activities and micro, small, medium enterprises, and it accounts for the 0.6 million. So similarly, you can see the improved cook stove and biogas losses, and similarly PV pumping. There is around 37 number of PV pumping damage. So we are now really looking forward to have a climate resilient and more resilient infrastructure in renewable energy technology in Nepal. So little bit, this is I'm just sharing the international scenario of one of the Australian utility, Horizon Power, is now moving more towards the distributed generation system. And there are three scenarios: 2016, 2025, and 2050. You can see really in the 2050 scenario, there will be 82% of distributed energy resources, DER, and there will be very little centralized system and standalone systems. So basically, the distributed energy resources, DER, offers various advantages of TND losses, less TND losses, and more reliable supply of electricity in the community. So if we think about the future energy systems, like developed countries also now coming towards centralized grid into decentralized or distributed generation, and also non-renewable energy to renewable energy, and some technology like blockchain something. So now the country like us, the developing country or least developed country, LDC, like Nepal, now we are also trying to do something with the distributed generation, and that is grid connected renewable energy technology systems. So it's not that we will be directly going towards our aim is to achieve like developed country and then again come back to the future energy systems. We will be directly going towards the future energy systems by having a more climate resilient renewable energy technology as well as distributed generation systems. And we will be also linking with the modern technology like blockchains. So what next then for us? So based on the learnings, like the Dipti was saying, that what happens when the grid arrives. Now we are thinking it's not that we will be building only micro hydro systems. We will be initially thinking that what will happen when the grid arrives. So the main aim is to promote the now distributed generation, that is grid interconnected micro hydros plants. So I will be now onwards, I will be talking a little bit about how we achieve this distributed generation in Nepal. So in fact, the micro hydro power plants in Nepal is less than 100 kilowatt, and there was no policy for interconnection of less than 100 kilowatt micro hydro systems into the grid. So we started advocacy back in 2011, and then the utility, we have only one utility in Nepal, Nepal Electricity Authority. So the Nepal Electricity Authority, NEA, comes up with the decision to interconnect micro hydro power plants having less than 100 kilowatt capacity in July 2014. And then again, there was some ambiguity in the decision made by the NEA. So it again took us 2 years to conclude that ambiguity in the decision. And the first power purchase agreement happened in February 2016. And let me tell you that the interconnection of micro hydro is totally different from the interconnection of the large hydro systems. So in terms of technology, there is a governor system in large hydro, and in terms of micro hydro, there is a electronic load controller, ELC. And ELC is, I think, less than 10 times less expensive than the governor. So we did not change to go with the governor system. We modify our ELC technology, and then we interconnect the micro hydro system into the grid. So the first, this kind of technology modification and technology identification, it took again 2 years to pilot the first interconnection project in Nepal. And last year, only in January, we have interconnected first micro hydro plant in Nepal. And the first pilot interconnection projects is a 23 kilowatt capacity, having 370 liter per second design discharge of gross head 11.4 meters. And indeed, these micro hydro plants has been built primarily to provide the electricity access in the vicinity. However, during the construction of the micro hydro, there is a national grid encroached in the micro hydro plant area. So the community switched over to the national grid, and then the community abandoned this infrastructure. So we went there and we concluded this pilot interconnection project back in 2018 January. So this project annually feed this 178,000 kilowatt hour, around 178,000 kilowatt hour annually to the grid. So far we have interconnected 4 systems, 23 kilowatt, 40 kilowatt, 90 kilowatt, and 100 kilowatt in different area in Nepal. And the PPA rate is currently 4.8 cents per kilowatt hour and 8.4 cents per kilowatt hour per month. And we have some projects in pipeline for interconnection. So hopefully in 2019 also we will have some interconnection projects. 24 are in pipeline. So in terms of technical aspects, this is technology, we have incorporated in interconnection of micro hydro systems. You can see from the bottom there is a generator, and in the right side you can see the electronic load controller. This is the different from the large hydro. Indeed, this is quite cheaper than the governor systems ELC technology, and there are some protection systems. And this is in the right, you can see the generator protection unit. This is all the functionality of control and protection system, numerical relay, and then this feed to the National Electricity Authority at 11 kV. The generation voltage of generator is 400 volt, and this feeds to the grid into 11 kV. In terms of financial aspects of grid interconnection,
2 more minutes, please, Jiwan, if that's okay.
Yeah, that's okay. So in the x-axis, there is a distance between micro hydro power plant to the grid in kilometer, and then this is a financial return, internal rate of return, IRR, without subsidy, any subsidy. So you can see there is a, like, if 5 kilometer distance, then this maybe blue line, you can see the 75 kilowatt. It's quite feasible. Even at the 10 kilometer distance, this 75 kilowatt are quite feasible. However, this is a marginally feasible. 50 kilowatt plant, this is green line, is marginally feasible because of the IRR percentage. So it's in terms of financially and business model, it's quite attractive for private sector as well. So as I said, that by micro distributed generation is mainly for the increase the reliability of the feeder line, as well as to minimize the T&D losses as well. So the impact we have observed is that when we interconnected this first pilot project in the 11 kV network, there was before interconnection it was 370 volt, and just after interconnection it increased to 382 volt. So there is an increment of 12 volt. If it would have, let's say, a 50 kilowatt, I believe that this voltage would have more improvement and then more reliable. So similarly, the T&D losses is minimized due to interconnection. And also, in terms of sustainability of the micro hydro plant, the plant load factor is increased to 58%. Previously, it was 25%. But again, we are facing some challenges, like we have several components for interconnection, and sometimes it makes complex. So we are looking forward to have compact devices and also more sustainable business model by involving private sector and finding subsidy for interconnection until the technology is readily available in the Nepalese market. And also we are looking to draft the distribution code for interconnection of mini hydro. And right now we have only PPA, power purchase agreement. So we are looking for our power exchange agreement, which can both having provision of export and import of the electricity into the grid, and also the standard power purchase agreement policy. And we are also looking to move from analog ELC, electronic load controller, to digital load controller, that is technology. So thank you so much.
Super. Thank you very much for that, Jiwan, for that very interesting presentation. And we have quite a few questions have come in there. If you have any more questions, then please do send them in. What I'd now like to do is invite my co-host, Dipti Vigela, to briefly summarize the 3 presentations and draw some parallels between their experiences, and then we will go into the Q&A session. So over to you, Dipti.
Yes, thank you so much to Longsang, Joe, and Jivanji for those excellent presentations. HPNet had a roundtable with Nepal members just a few weeks ago, and it became clear that the investment in a multi-actor approach is evident in the Nepal context. So yeah, one thread that goes through all of your work is that you either are bringing together different sets of stakeholders or are actually examining the outputs of the work of multi-stakeholder programs. So I think this is very critical in other countries where we have, such as Myanmar, where I'm currently based, we have multiple donors working on decentralized renewable energy, and how well is the coordination going? How well do they coordinate among different stakeholders? So I'm fascinated by this thread among the three presentations. Another is, of course, this core aspect of resilience. You know, it's not just technology, it's not just policy, it's not just community, it's the overlap of all of that, and also environment, watersheds, and this is actually how HPNet has resulted in a multi-actor network, which actually we work very closely with all three of these speakers on bringing in the regional experience and multi-actor experience, multi-thematic areas of work. So, and lastly, you know, how does this research and the hindsight examination lead to tomorrow? Lead to what, you know, what mechanisms can be designed based on the output of these research questions being answered, and of the program that Jeevan-Ji leads. This is critical in the case of Nepal, where there have been decades of investment, and how do policies and processes, how can they be adapted to what's happening now? One important note to feature is that recently the Nepal policy has, the Nepal constitution mandates that energy policy, energy programs must be designed at the municipal level. So some of the aspects that Jeevan-Ji explained, this grid arrival, resilience, the mechanisms for training, etc., will now be anchored at the local government level. So how does the Nepal context need to transition from what was a very centralized effort at the AEPC to now AEPC's role in really empowering municipalities? So yeah, let's move on to the questions.
Excellent. Thank you very much for that summary and for those thoughts. I will just make sure that now all of our speakers can join us again. So if you want to unmute themselves, and I will read out some of the questions that we've had coming in. The first one, I think, is a subtle yet fascinating and very important question, and very important in the context that we were talking about off-grid systems, then combining with on-grid ones to form complex systems. So that question is: should the focus in discussions like this, and indeed the focus in the considerations of community, be on security of energy, energy availability, or security of the particular energy service? And maybe we can start that one with Long Seng.
Yeah, so sort of the difference between two senses of energy security in terms of the service or the supply, is that correct?
Well, I guess it's the particular service, the main technology that you have there, or whether you're looking at security of energy availability, and therefore, you know, you maybe have some alternative technologies there to ensure that, you know, some degree of energy can continue to be made available.
Yeah, I think that goes back to the diagram, you know, at the beginning, and sort of what role does the physical system play in broader energy security and resilience, and then therefore community resilience as well. I think perhaps I'm missing you know, some of the finer differences between energy service and availability here, but I think what came through to me, as I said in those workshops, was this: how central energy services in identifying what critical services are in disaster situations. I think that was one major thread that came through. And then again, a second layer of that availability as well. How do you then ensure that there are supplies available to meet those needs?
Yeah, Joe, do you have any insights on this?
Yeah, so I would say that my experience in Nepal is that people tend to be quite flexible, and that often there are alternative sources of energy that are available. So when asking people what do you do when the hydropower plant is dysfunctional, then they were able to obtain kerosene or chargeable lights in order to fulfill their basic needs. But I would, in Nepal, I would make the argument that a well-sustained, reliable hydropower plant can meet all of their needs, and above and beyond those basic ones that kerosene or candles would.
Great. And Jiwan?
Yeah, so I think energy service, continuous energy service is a very important part, and people's perception is that micro hydro has some kind of I say that little bit more outage compared to grid systems. However, we faced rolling blackout of around 15 to 16 hours every day in the grid, and then people perception has been changed that the micro hydro systems are more reliable, and then if there is some small damage in civil infrastructure, then they themselves go and repair to get back their electricity service within an hour. But whenever there is a major damage, they cannot afford the cost. So then again, they go back to see the availability of public money. So yes, I would say that energy security is very important for them, even for the economical growth. And if someone is running business and it is the electricity is supplied through the micro hydro, the continuous running of business is very important. So if we have observed that if some micro hydro has a more productive in usage and more businesses that are more reliable and more continuous supply of electricity. So we are also thinking of providing post-installation support and more promotion of productive in usage to increase the reliability and energy security in the vicinity. Yeah.
Good. Dipti, do you have any opinion on this?
Actually, the current stakeholders in Nepal are working on solutions for different aspects of reliability, and I can share specifics. I think I will just ramble on if I go into them now, but I can share through email or other communication.
Some examples of that. Yeah, I thought this was a particularly interesting question because of some of the aspects of energy security and community resilience that we've looked at in the Smart Villages project, and in particular, one of the interesting ways that we think that the grid-connected world could actually learn from the off-grid community, because it struck us that in a lot of places, grid infrastructure can be much more significantly damaged by natural disasters than decentralized infrastructure, and therefore we saw the examples of the hurricanes in the Caribbean a couple of years ago, and other natural disasters around the world, where it actually takes a very long time to build back that gross centralized infrastructure. But in fact, if communities have a small degree of decentralized infrastructure, they can continue to exist. So I guess the evidence from what we've seen is that actually both are important, and that the community probably wants its focus to be on energy security for that community. So they want to have some alternative technologies available, as Joe was mentioning. But for the people that are constructing the energy service, it is incumbent on them to try to make their infrastructure as resilient as possible. And in cases, obviously, where that nothing can be perfectly resilient, but to try to construct it in such a fashion that when a natural disaster does occur, it is repairable as quickly and as cheaply as is possible, so that we don't see some of the very high costs of repairing damage that we saw in Jiwanji's presentation. Good. Well, thank you very much for your responses to that question. I think another interesting question that's come up relates to productive use, and to what extent our three presenters have looked into the types of productive use activities which are linked with the provision of the energy in these communities, and to what extent productive use contributes back into reliability and resilience of the energy. So again, if we can, let's start with Joe this time.
Yeah, so unfortunately I had some slides on this that I had to take out to do with time restrictions, but we did, for all of the sites that we visited, we collected information not only on the number of connected households, but also on the number and types of productive end use, and we saw a huge variation in these, and again, kind of in a similar thread to some of the slides in my presentation, the benefits of productive end uses in terms of the sustainability of the plants do also tend to favor the plants of higher capacities. For example, the largest plant we visited, they were connected to a large-scale stone crusher, which used almost all of the power of the plant during the day. So in terms of their income, whereas the smaller plants might struggle to have a good load factor during the day, they actually had this one very large use. But for all of plants, regardless of the size, those which had a diverse range of end uses tended to be the ones that reported having the best ability to pay for repairs. I think mainly because they can spread those uses of electricity throughout the day and also the night to try and maintain a good load factor. So I think, yeah, diversity of the end uses is really important in the sustainability of the plants.
Great. And Jiwan, do you have any comment on that?
Yeah, in fact, most of the off-grid systems sometimes struggle with the financial sustainability. And one of the reasons is that what I'm linking is that like in off-grid systems, the investment in kilowatt, and we see the return in kilowatt hour. It's totally different from the other commodity in the market. So to link this kilowatt with kilowatt hour, there is one linkage called load factor, like Joy was also mentioning. So if plant has a good load factor, it has a more financial sustainable and poor load power factor and poor financial sustainability. So to increase the load factor, again, the end-use promotion, productive end-use promotion is very important, and at the same time diversification is very important. If let's say if you are promoting productive end usage in the evening time, at the same time there will be loading of electric, there will be some household consumptions and other consumptions. So the diversification is very important. If I am installing 50 kilowatt of plant, and if there will be usage of 50 kilowatt in 24 hours, it's very good. So diversification is also very important for the sustainability of the micro hydro systems. Yeah.
Good. And Longseng?
Yeah, A great question. I think Joe and Jiwan have already addressed the link between productive uses and improved financial sustainability of the micro hydro plant or other kinds of renewable energy systems. But there's also a direct link between productive uses of energy livelihoods and therefore, better financial capital and reduced vulnerability of communities. So productive uses of energy can be directly linked to community resilience as well as the technical sustainability of their energy system.
Super, thanks for that. Now there have been a number of questions which have alluded to the way that the community interacts with the technology and the energy supply systems and what's optimum there. So if I can slightly conflate all of those questions together and ask whether our speakers have any views or evidence about whether there are any particular sort of community ownership and management models which lend themselves to really optimizing the resilience and reliability of systems. And if we can start with Jiwan on that.
Okay, so in fact, we have a learning of more than 20 years in this micro hydro sector, and so far we are practicing that once the micro hydro systems has been built, we simply hand over it to the community for the operation and maintenance. But this model really, now we are realizing that we need to change this model. In fact, in this model, if there is something happens, they again come to the AEPC and again asking for some kind of financial and technical supports. So our intention is to involve private sector right from the installation of the plant to the operation. So if it's not only the private sector will be going and installing the system and coming back again and having the financial return of their installation and product. So we are now thinking to involve private sector in equity. So private sector will be putting some equity money in the systems, and that equity will be returned in the 5-year terms or maybe in the 7-year terms. So there will be involvement, regular involvement of private sector in the community. So we have a provision of service subsidy, in fact kilowatt hour subsidy. So now we are moving towards the kilowatt hour subsidy. If let's say the LCOE, levelized cost of electricity of off-grid systems comes to be, let's say 50 rupees, then we can subsidize 60%. So the community will be paying only 20 rupees and the private sector will be getting 30 rupees from the as a subsidy. So we are hoping that this kind of model will be very sustainable and also lead to more sustainability of the micro hydro plant and more energy secured service for the off-grid community.
Good. And Longsang?
Yeah, I think what's really important trend that's emerged both from my own research and the networking workshops that I've been running is that action at the community level is key, after natural disasters, but also in preparing for them and recovering as well. And I think that local level action must be inclusive. So, the work done to include different sectors of society, but also different other infrastructure planning at the community level, both has payoffs in terms of resilience and development.
Thanks for that. And Joe?
Yeah, so I would say I've seen a range of sites, some community-owned and cooperative, and some private, and each of those forms of management, I I've seen examples of it working and not working. I would say that generally the sites which were cooperatively owned, and this is purely my own anecdotal evidence, the cooperatively owned ones often had the influence of business owners who might take a slightly larger share in the hydropower plant, and they were able to kind of implement their business understanding or their management experience into the management of the plant, and often that seemed beneficial to the plant. I know that Winrock International were doing a project to try and improve knowledge sharing between plants, and I think that that's quite important, because in a geographically small area you can get plants with really successful forms of management very close to unsuccessful ones, and the same in terms of approaches to operation and maintenance.
Thanks for the insights there from all three of you. And staying on this question of the community and drilling down maybe a little bit more, another question that's come in is whether our speakers can elaborate at all on how communities themselves and how maybe the electricity users associations, where those exist in the communities, how they have actually acted when there has been a disaster, either a natural disaster or some other problem with the energy supply, how they themselves acted to recover their energy services. And start with Long Seng on that.
Yeah, so I did allude to this in my presentation. So in Nepal, the National Association of Community Energy Users, which is a federation of almost 300 community rural electric entities, CREs, which interface with the National Electricity Authority, which is the electricity utility in the country, were quite central both in development of energy in non-disaster situations, but after the earthquake in 2015, they formed a really central mechanism for the recovery process. So through the National Association of Community Electricity Users, they were able to support these individual CREs, Community Rural Electric Entities, both in hardware and also in capacity enhancement for actually repairing those distribution lines. So I know that they were able to provide funds quickly to the CREs and also provide some training, and communities really mobilized themselves to put up poles or to repair the conduit as well. So I think for me that was a really hopeful sign that even for something like a electricity distribution system, fairly complex, that communities were able to mobilize to recover as well.
Excellent. Jiwan, do you have anything to add?
In fact, during 2015 earthquake, we had a outreach system all over the Nepal. So we had outreach offices in each district, and in each district we had district engineers who were providing technical support to the community for rehabilitation of damaged microhydro systems. And if there is a minor damage, the community themselves, they were putting their money to revive the systems. If there is a major damage, the government of Nepal had allocated money for additional subsidy for the rehabilitation of microhydro plant. So at that time we had a very good structure of providing technical support locally. It was not centralized, in fact. But currently we don't have this mechanism, and we have only service center and regional service centers. So regional service centers is providing the same technical support to the community to take care of their systems. And also, I would like to share that, in fact, during the installation and before the installation, in fact, we have a very strong mechanism of community mobilization. So because of this community mobilization, the community people are very strongly attached with the systems, with the technology as well. They contribute voluntarily for the construction of the canal and other civil structures. So they do care the systems as like their private asset. Sometimes that kind of feeling also work. Yeah.
And Joe, anything else to add to those insights?
I visited a few sites which have sustained significant damage, so where a large proportion of a micro hydropower plant needed to be rebuilt. And in speaking to generally managers of those plants, the ways in which they recovered tend to be quite different. There was no kind of structured form for recovery, and generally it involved a mixture of bank loans and individual contributions from the community or from wealthier members of the community. So I haven't really experienced much of kind of a resilient response, but in the cases that I've seen, it varied a lot.
Yes, it sounds like from all three responses there, the degree to which there can already be a sort of a plan or a system or an infrastructure in place for being able to deal with those queries from communities and help them to recover. The faster and the more successful the recovery is. One final point before we move on from communities. Do our presenters have any evidence? A question has come in here. Of whether inclusion of diversity in user group committees and management committees, so making sure there's good gender representation or involvement of different castes and different people from throughout the community. Any evidence of whether that adds to the resilience and reliability of being able to manage the energy supplies? And Dipti?
Yeah, I would like to share experiences from the region where, especially in some cultures of South Asia, where you have different types of hierarchy in the social structures, for example, the caste system in India, where we see that the implementation process, the 6 to 9 month, 1 year process of assessing the stream flow, designing the system with the community, the distribution line, all of this coming together, the tariff structures, the ownership models, the productive end use, that process of working with the community, if we ensure it is inclusive, it ends up creating resilience, stronger resilience. So, for example, in one of the projects that I supported in Orissa, India, we had one landowner that was the only one that didn't take a connection. He was going to wait for the main grid to arrive, and he ended up bribing one of the operators to connect his household a few years after the system was running. And it was really the women who came together from the 3-4 different tribal ethnic groups and castes of that. It's about, I think, 60 households that went to his house and removed the pole and said, you didn't contribute to the system and we cannot let you use it. So it was because the project was implemented with an inclusive process that this resulted. And secondly, it's just the innate nature of microhydro implementation. You're involving watersheds. water used by the entire community, it's just the whole linkage between the communities and the natural resources that really lends itself to community-based ownership.
Thank you for sharing that, Dipti. Any of our other speakers like to weigh in on this question of diversity and community energy management?
So I know that often in programs in Nepal, I think caste and gender inclusion is heavily promoted. What I don't know, and probably talked about in the earlier stages of project planning, I'm not able to comment on further down the line whether that involvement is retained. On my study, I think we met with a few female managers and no female operators. But in Nepal, I think often women's groups do have large impacts in communities. Someone was telling me the other day that often they take a lot of responsibility for community forestry programs. So this colleague was making the suggestion that a larger involvement from women's groups in energy projects could definitely be a good thing, particularly in some rural communities where women are more likely to stay in a village for a long time, unlike some of these operators who are moving away.
Jiwan, you have more in-depth knowledge of this than most of our presenters and contributors. What's the situation that you've seen?
In fact, I would say that Nepalese society is a little bit male-dominated, and most of the household work and kitchen works had to done by the ladies in the houses. So the value of electricity in the off-grid community is really understood by the females, and they are more sensible towards the electricity while you will be comparing with the male. So also another problem in Nepal is that the turnover of male staffs, maybe operators, is quite high. So the systems, the plant which is operated by women, we have some plants. It's not that only the male operators is working in micro hydro. There are quite a few number of plants which is operated by the females, and we have a mandatory provision of female representation in the user group, user committee. So it's a mandatory, and we have a 6th principle of community mobilization, and in that principle it is really mandatory to have a woman in the user committee and all the community organizations. So we have seen that the systems managed by the females are more sustainable. In fact, in the other off-grid technology, like in solar mini grids, we have recently conducted some sort of case study, and we have seen that the female operators are managing the solar systems very well, and they were cleaning the panels, they were checking the battery and every systems. At the same time, there was just in the same community, I would say that in the nearby community there is a solar mini grid, another solar mini grid which is managed by the male operator, and we had recently went to check how they are doing. So the male operated solar mini grid, there was just they were not properly managing the water in the battery. Even the panels were not so clean and dirty. So we think that we instructed our field coordinator to rearrange the user committee and more representation of the female. So we are learning that the female the system operated by the female are more sustainable, and we are very committed on the gender equality and social inclusion as well in all the off-grid systems.
Great, thank you for sharing that. And Longsang?
No, I think there were great examples and evidence for female participation in providing energy services. I also, drawing on my own experience working with communities in Nepal, I think that all the work that has gone into gender equality and women's empowerment does shine through, I think, in the advocacy around, demanding energy services, even if women don't have access, say, to education or the right technical capabilities to be involved in those more technical aspects without specific training, then they are still incredible advocates for how it's actually used and how it's distributed within the community. So I think there is definitely a strong link between the empowerment aspects and then the getting a better product at the end.
Super, thanks for that. Well, we're in fact very slightly over time, so there's just one more question that I would like to ask, and I'm going to challenge all of our presenters to give me a 30-second answer to it. So this is a question which says, we've obviously been talking about everything in the context of Nepal. To what extent has everything that we've said today about resilience and reliability of energy systems, to what extent is that specific to Nepal, or to what extent can other countries implement the same sort of philosophy in systems in their own countries? So 30 seconds, maybe starting with Longseng.
Yeah, I think Nepal does have a lot of expertise both in renewable energy and in dealing with disasters, so in reducing and understanding risks. So there's definitely a lot of technical things that can be learnt there. And I think they're well networked with colleagues globally and in South Asia. So I think there's already been quite a good exchange. And what I'd like to say is that I think there could be even more exchange between disaster risk reduction experts and energy access experts to further explore these ideas. I've certainly found that really fascinating within the workshops that I was leading.
Great. And Joe?
I think Nepal is well established, particularly in micro hydropower, and definitely, as we've heard from Jiwon, has support from government. But in terms of developing the systems and integrating them with communities, an understanding of the local needs is required. But hydropower remains the same wherever you are. So the technology can be implemented. It's just understanding how best to get communities to use it.
Great. And it's only fitting then that the last word comes from Jiwon.
Yeah, so Nepal has, as I said in the presentation, has experience of 20 years in the off-grid sector, and we have piloted several business models and also the community-led models. So I think this can be replicated in entire region, and not only in Nepal. So Nepal's like community mobilization, institutional setup, this kind of learnings can be replicated in other parts in the world as well.
Super. So the rest of the world can learn a lot from Nepal's experience on this. Great. So we have come to the end of our time. It remains for me, on behalf of the three co-hosting organizations, Smart Villages, the Low Carbon Energy for Development Network, and the HPNet, Hydro Empowerment Network, to thank all our three presenters, Dr. Longseng To, Joe Butchers and Jiwon Kumar Malik, for sharing their expertise with us so generously and answering those questions and discussing them at the end. And to thank all of our attendees around the world for giving of their time to have this very interesting discussion with us. We thank you all very much for joining us, and we very much hope that you will not only watch the video and the presentations of this session again, which will be accessible via our website, but that you will join us sometime in the future for one of our future webinars. Thank you all very much, and we look forward to you joining us very soon. Goodbye.